Okay, so starting on your homework sheet based on what we just learned, cross sections is usually pretty easy, makes us really happy because you just get to add up geometric figures. All right, so for instance, adding up is we're going to sum up. If it's rectangles, we'll do length times width, which we've already done, but that would just be two-dimensional rectangles. What gives you your third dimension is the base. And then things will be popping up out of it based on how big they are. And the dx is just the width of it, like you may have seen in the short video, because each of them have a little bit. If I pulled this triangle out, it would have a little bit of width on the side, just looking at it on the side before you look out at the triangle. And so this dx is just how skinny this little thing is, like a coin or something. I think of it a lot like Pringles, a stack of Pringles, or crackers, or something that paper, a ream of paper, a stack of paper. They're just really, really thin, and you could add up all those rectangles and get the volume of paper. So you're adding up geometric figures. So if it's a square, you're going to say the area of the squares that you're looking at that are popping up out of some figure would be side squared. And then they would have a little bit of width on the side, dx. If what's popping out is triangles, you're going to add up the area of a triangle. If it's a right triangle, you'll of course do 1/2 base times height. If it's equilateral, you can go straight to the square root of 3/4 side squared. You're welcome to do that. Square root of 3/4 side squared is an equilateral triangle. Let's develop that once and for all, and then you can use that formula. First of all, I should draw it equilateral. If it's equilateral, one way you could use it is Heron's or Hero's formula. With that formula, these sides are all the same. Hopefully you learned it in pre-cal. You add up all three sides. So you get 3s, and you take the semi-perimeter. And then you put it in the square root. So you take this minus, so you take this, 3/2 s. Then you say 3/2 s minus this side. So you get 1/2 s. And then you do it minus this side, so you get another 1/2 s. And then you do it times this side, and you get another 1/2 s. So you have the square root of 3 over 2, 16. 1, 2, 3, 4, s to the 4th. The square root of 3 is the square root of 3. The square root of 16 is 4. The square root of s to the 4th is s squared. You don't need absolute value because it's squared. So you can go straight to this for volume. You can also do it with area of a triangle, like 1/2 a, b, sine of one of the angles, which is 60, this angle between them. Again, you should have learned that. This is 1/2 s squared. Sine of 60 is √3/2. So you also get square root of 3/4 side squared. You'll see me using that for equal. It's going to be my go-to for an equilateral triangle. All right, so let's get started on number 1. And I've taken a picture so that I'll have room to write. So, and I probably won't do them all. I may set some up and let you finish them, or set some up on your own. You have all the answers to them right down here. All right, so let's look at the first one. All right, so on 1A, so what we have first is we've got to get whatever the base of our object is. So in class, I would start picking up 3D objects. You should maybe do that at home. I have all kind of things like candle holders that might have an octagonal base, but with other objects sticking up out of it. I see an angel over there with an elliptical base with other shapes popping up out of it. Again, if you think of a glass that I just drank some water out of with a circular base, I can't draw these very well, but if you took a cross section of it, if you thought about it, it would actually be, each of these cross sections would be a rectangle. It's really a bunch of rectangles growing and shrinking based on the circular base. A lot of times I don't really have a hard time visualizing them, but I can still work them. So if you're that person also, don't worry about it. All right, first thing you want to do is get the base. They got an interesting base here of y equals x plus 1 and x squared minus 1. So it goes like this. And so the base of this object looks like this. Okay, so if you picked it up and looked at the bottom of it, you would see like that's the base, but all sorts of things could be popping up out of it to make different figures. All right, so first of all is squares. So again, I'm happy, I like these are really easy. If it's squares, whatever is planted in the base is going to be popping up, side squared. These look like these are really good to do in terms of x. So I'm going to do dx. I'm going to find out these intersections and sweep across, and I'm going to have squares coming out of here. Another reason I had you watch the video is I can't draw very well. You'll have these little squares coming up out of bounded by the base. The squares will start out small, really like even 0 at first, and you'll get bigger squares to make more interesting. You get back small again. Thank goodness there's other visualizations I can give you. All right, let's find out where these intersect. Where does x plus 1 intersect x squared minus 1? At x squared minus x minus 2. And so I get 2 and -1. So I'm going to go from -1 to 2. Now the side is going to be created by top minus bottom. All right, so I'm going to go the top is the line minus the bottom. Those are going to give me one side, and the other side's coming up at me, like toward me. And so the base of the square is line minus curve. All right, so one of these, and then it's, so one of these, and then the rest of it's poking up out of me, but it's a square, out of the figure, but it's a square. All right, so I'm going to have line, let's get some more room here. It's squares. So again, you're just doing geometry, side squared. They're going to have a little bitty width and go from -1 to 2. All right, so the line minus the curve. Don't forget be careful with your minus. So we'll do this one. This is x plus 1 minus x squared plus 1 squared. And then we'll check our answer. So this is 2 plus x minus x squared, but unfortunately it's squared. So we got to figure what that is, because substitution will not work here. If I let u be the inside, I don't have enough to compensate for it. So this is 4 plus 2x minus 2x squared plus 2x plus x squared minus x cubed minus 2x squared minus x cubed minus x to the 4th. All right, so I have integral from -1 to 2 of 4 minus 2x plus 2x cancels out, minus 2x squared, minus 2x squared is minus 4x squared, plus this x squared is minus 3x squared. And if I could miss it, this is probably where I'm going to miss it, minus 2x cubed minus x to the 4th. So tedious, but not too hard. 4x minus 3x cubed over 3 minus 2x to the 4th over 4 minus x to the 5th over 5 from -1 to 3. Top minus bottom gives me 12 minus 27 minus 81 halves minus 243 fifths. -1 is going to give me -4 plus 1 minus -1 to the 4th is 1 half minus a -1 fifth. Let's see if any of this, let's see, that's going to be negative, let's just write them out. -15. I'm going to leave it 81 halves minus 243 fifths. This is going to be minus -3 or plus 3. I have a minus negative, so it's plus 1 half minus 1 fifth. All right, so we have -12. This is going to be minus 80 halves, so that's minus 40. And then this is minus 2, nothing nice, 2/44. All right, so negative 60/5. Wait, I shouldn't be getting a negative. I feel like I've done something wrong here. Was it line minus curve? Let's see, what did I do wrong? Maybe with my squaring. Sorry, I'm going to go really slowly this time. And hopefully I won't do this again. All right, so I had top, x plus 1 minus bottom. Make sure I copied them down right. Now let me go a little slower. Haste makes waste. X plus 1, top minus bottom. So that gave me, and then that would be squared because it's a square. So this is the bottom, and then there's a part sticking out. And I am going from -1 to 2. So you may have caught what I did wrong, but I don't know what it is. So this is negative x squared plus x plus 2 times negative x squared plus x plus 2. That's x to the fourth minus x to the third minus 2x squared minus x to the third plus x squared plus 2x minus 2x squared plus 2x plus 4. So I have x to the fourth. I have minus x cubed is minus 2x cubed minus 2x squared is minus 4x squared, so minus 3x squared. We get 4x. And at the end, I think this is a 4. So hopefully this is right. All right, so I have x to the fifth over 5 minus 2x to the fourth over 4. Be 2x to the fourth over 4. Minus 3x cubed over 3, so x cubed, plus 4, I don't think I had this one, 4x squared over 2, so 2x squared, plus 4x from -1 to 2. All right, so this is 32/5, which, oh, I even looked at my 2 as a 3, I'm sorry. This is a 2. Minus 16/2 minus 8 plus 8. Oh, this is a lot easier. Sorry. I looked at my 2 as a 3, or probably turned it into a 3. -1 to the fifth is -1/5. -1 to the fourth is in 1/2, but it's behind a minus sign. This one's going to be a negative behind a negative, plus 1, plus 2x squared minus 4. So all of this, if I did it right, cancels out, and I have 32/5 minus negative or plus 1/5. Oh wait, what is this? Let's see, I was filling in -1. That was 1, that was 2, and then minus 4. All right, so this was plus 1/5, plus 1/2. All right, and this part is 3 minus 4 behind the negative. So that's going to be plus 1. So I have 33/5. This is 5/10. I need it over 5, I'm sorry. So we'll get it all over 10 in a minute. We'll call this one 3/2. All right, so 10. So this is going to be times 2, and this is going to be times 5. All All right, so that gives me 81 tenths. All right, let's check the answer and hold our breath. Good, 8.1. All right, so let's remember 4.5. All right, so again, take your time. All right, now, since it's video, you can rewind. Sorry about that first mistake. And I'll leave my graph kind of alone a little bit so we can look at it, or at least we can slap it on there really quick. All right, so we have x plus 1, x squared minus 1, and they intersected at -1 and 2. All right, so we have this in here, and we have a top minus bottom. This is just what's landed in the base as we just slice it from overhead. Then if we rotate it and look at it, rectangles of height 1 are popping out of it. Like rectangles of height 1 are coming up out of it, like if I twist this around and stick it right there. All right, so I'm going to add up rectangles. So again, that's why I like them. I'm just adding up geometric figures. I can certainly add up rectangles. I need length times width. And then they have a little bit of a dimension on the side. That's our dx, because they have a little bit of a thickness, because they would be right next to each other. All right, it's going from -1 to 2. So remember, these are 3 dimensions. This is how wide like a piece of paper is, or your book, something really thin like a potato chip. All right, and then we're going to get the other 2 sides. So the base of it is right here, top minus bottom. And so that's going to be x plus 1 minus this, which ended up being minus x squared plus 1. That part was negative x squared plus x plus 2. All right, so that is just the bottom of the rectangle. All right, so that's negative x squared plus x plus 2. Now we need the height of the rectangle, and they said each one of them would have a height of 1. So each rectangle, as they vary in width, will have a height of 1 as they move across here. They really are going to be this way, actually. And they're rectangles, and the little bit of width is caused by the edge here. All right, so that's this. The height is 1. So this is length times width, or base times height. All right, thank goodness it was 1. But if it was 7, I would factor it out and then do my integral. All right, so this can be easier because I don't have to square it. This is base times height times width. That's why it's volume. Negative x cubed over 3 plus x squared over 2 plus 2x from -1 to 2. All right, so if I fill in 2, I'm going to get -8/3 plus 2 plus 4. If I fill in -1, I'm going to get 1/3 plus 1/2 minus 2. Just be careful with that. Me too. This one, if I fill in 2, what did I say I was going to get? If I fill in 2, that's going to be -8/3. That's going to be 4/2. Okay. So don't worry too much about common denominators at first. You have -8/3 minus 1/3. Let's group those together. Then I have 6. This is -3/2 behind the minus sign. So plus 3/2. This is -9/3. So this is -3 plus 6 plus 1.5, which looks like that should give me 4.5, which I think we said was the answer. All right. All right, C, semicircles. So now I'm going to add up semicircles. All right, the area of a circle is pi r squared. All right, so let's draw this a little bit bigger. Probably should have done that from the beginning. We have a figure that looks a lot like this. And this is -1 to 2, so it's not really drawn to scale very well. But we're going to come and slice it perpendicular to the x-axis, so we're cutting, and what's falling off onto the cutting board could be squares or rectangles. In this case, it's semicircles. Now be careful. You don't have the radius of this. You have the diameter of it right here. These are diameters and they're semicircles. So I want to add up the area of a semicircle, and then when I multiply it by dx, it'll have a width. So these semicircles, if I pull one out and look at it, so let's pull one out and put it up here, okay? So when I do the area, I'll get this, but remember that these rectangles themselves have a little bit of width. So it has like a little bit of width going around, but it's infinitely small. That's what the dx is. So I have 3 dimensions, and so the area of the rectangle would be just 2-dimensional. It'd be pi over 2 r squared, and the dx is this little rim around made by the width of however big your rectangle is. We'd give it like a little bit of a depth as you go around. All right, so we knew the inside of it. I wish I'd written it down. When you're looking at your work, you can go back and look at all of that work that you did, which I think I've lost. I think this is even my incorrect work when I was actually filling in a 3. No, that was right. All right, so anyway, it would have been nice had I kept the top minus bottom somewhere on my sheet here, because I still get top minus bottom, which was x plus 1 minus x squared plus 1. Factor out the pi over 2. And once again, we have negative x squared plus x plus 2 squared. And if you did it carefully the first time, you could repeat that again. I'll let you finish this one. Hopefully you have on your notes what this was. Integrated actually from -1 to 2. In fact, let's do that. Let's check that out. Remember this whole entire thing for the square, which is what that would have been. We ended up getting 81 over 10. And now I'll swap by pi over 2. So I get 81 pi over 20. Let's see what we got up here. Why am I getting 9 pi over 4? Because that doesn't reduce. Didn't we get 81 over 10? We had 8.1. So we have this, gave us 8.1. And so this should be 8.1 times pi over 2. I just don't see why it reduces to 9 over 4. I must be doing something silly. Let's see. I'll do 8.1 times pi. I'm taking for granted these answers are right. Let's see, 81 pi over 20. All right, I'm getting 12.723 when I do this. So maybe C is wrong. Let's work it all the way out and see what we get. All right, so you can see our setup here. Sorry, let me quit this program. So we can see our setup here with the squared. And so I think you see what I'm saying. So maybe this one is wrong, but let's do it out. So I'll do this part squared. So I'm going to have negative x squared plus x plus 2. We've already done this. Once wrong, once right. All right, so that gives us x to the 4th minus x to the 3rd minus 2x squared. I'm on this one, minus x cubed plus x squared plus 2x. I'm on this one, minus 2x squared plus 2x plus 4. So I have x to the 4th minus 2x cubed. It's a good reason to show your work because you would have it left. Minus 3x squared plus 2x plus 4. I believe that's what we had. So if I do all of this out from -1 to 2, I'm going to get the same thing. I'm going to get x to the 5th over 5 minus 2x to the 4th over 4, so that'd be over 2, minus x cubed plus 2x squared over 2 plus 4x from -1 to 2. And so all of that should give us 8.1 because that gives us 32/5 minus 8 minus 8 plus, all right, something's wrong with this one. What did I do wrong here? Oh, this was 2x and 2x, this was 4x. And so this was 4x squared over 2 or 2x squared, because remember that one was an 8 and an 8. And then when you fill in -1, you get, there's a plus in here, -1/5 minus 1/2 plus 1 plus 2 plus minus 4. Which is kind of a waste of your time right now for me to do this all over again. But 32, this was minus, I'm sorry. Squeezing it in because I feel like it's got to be 8.1. So it was 31/5. Oh, it's minus a negative. So this is plus 1/5, 33/5. I remember this was 1/2. So it was minus 1/2. This was -2, so that's plus 2. 33/5 plus 1.5. So yeah, we got 66, multiply that by 2, multiply this by 5. So that was 81/10. All right, so this answer right back here is incorrect. This would have to be 8.1 times pi over 2, or 81/10 times pi over 2. So I should have trusted myself at the beginning because there was no reason for that not to work. So let's use that to our advantage here on this last one. Let's see what D's setup is. You can see equilateral triangles. So coming up out of this base now is equilateral triangles. So they're going like this and poking up like equilateral triangles and making some kind of really cool figure. All right, so you can go straight to square root of 3 over 4 side squared. But we know the sides are once again this part, which was x plus 1 minus x squared minus 1 or plus 1. That's just the triangle. This dx gives it its little bit of width. It's all crazy skinny though, like skinnier than a piece of paper. Very slender. So from like -1 to 2. So based on what we just did, we should be able to say square root of 3 over 4 times, we've already done this a couple of times, 81 over 10. So I'm getting 81 root 3 over 40. That's what I'm getting. 81 root 3 over 40. So there was some sort of mistake on C. This is the answer to C. All right, going to number 2. All right, so this is a circle. The base is a circle. So so it's like if you picked up your coffee cup and you looked at it, suppose your coffee cup looked like this, little handle. Actually, the cross sections, if you think about the three-dimensional aspect of it, the cross sections would actually be trapezoids. I don't know if you can envision that, but there's trapezoids getting smaller and bigger as they go around your circular base. When I'm in person, I have ways to show you that, but this is a circle with a radius of 2, centered at the origin, because it's x minus 0 squared and y minus 0 squared. So they usually give you really easy circles. All right, now I've got to solve this for y. Y squared, we're perpendicular to the x-axis, so I want to get it in terms of x. 4 minus 6 squared So when you square root, remember we have this plus or minus. So we really have two functions, the green one and the blue one. All right, so this is our blue one right down here. All right, so this is our top minus bottom, green minus blue, perpendicular to the x-axis. And poking up out of them is going to be squares again. All different size squares bounded by that base. So I'm going to have the integral from -2 to 2, but I'm actually going to do this. I'm going to double it from 0 to 2 and just do this side of it because I'm convinced of the symmetry that the same thing's going to happen over here. All right, now remember we had this. I'm just doing this side of it and doubling it. But to make them two functions, I have the green and the blue. All right, so our slices, as we so something's coming out of the iPad onto us or out of your paper, and you're just cutting over it, top minus bottom, and that's the base of something. Right now it's a square. So coming up out of it would be squares. So this is side squared. All right, so the green minus the blue. All right, so it's going to give me square root of 4 minus x squared minus negative square root of 4 minus x squared, which gives me 2 of these. All right, which makes sense because it's this much doubled. Okay, now I can take this, be careful, you got to square it first. I was about to take this 2 out, but not yet. 2 integral from 0 to 2. 2 squared is 4. The square is on the outside of the square root, so I can just call this 4 minus x squared. Remember this 2 is because I've doubled it. If you ever put something in your calculator, don't forget to put the coefficients in front of it. Here I have 8 from 0 to 2 of 4 minus x squared. And, you know, I tend to mess up on the easy stuff here at the end, so let's see if I can make it through. 4x minus x to the third over 3. Don't forget your 8, as in I've forgotten it lots of times. Keep up with it in your calculator or in your work. All right, this is going to be 8 minus 8 thirds. Don't neglect filling in 0, but it does give us 0 this time. All right, so this is 24 thirds minus 8 thirds is 8 times 16 thirds. I'm getting 48 thirds. And I should have gotten 100 and, oh, why did they multiply it by 4? Oh, I had an 8. I should have had 128 thirds. So hang on, made another careless mistake somewhere. Coming up out of it are squares. These are really easy. It could be that they messed it up again. Let's see. So top minus bottom is doubled, and that's a side squared. Let's see. We have the same setup, so I must have made a careless mistake again. Sorry, girls. What do I mean by we have the same setup? They have a 4, but they went all the way from -2 to 2, so they didn't double theirs. So my 8 should have worked. So back again, catch my mistake. I don't see what it is. again, this is, I don't mean to make the point this well, that you really need to be careful and do your work on the back end. Also, don't skip that because obviously I'm prone to make a mistake. All right, this is this distance. That would be square root of 4 minus x squared twice, all the way to the bottom. So you have two of those, square root of 4 minus x squared. And when we square it, I have this. I took out the 4 and made it an 8. So I have 4x minus x to the third over 3 from 0 to 2. So I get 8 minus 8 thirds minus 0. So I get 24 thirds minus 8 thirds. Oh, I think I just didn't multiply 8 by 16 correctly. I don't know what I did. All right, so I think I got that far and didn't say 128 over 3. I guess I could start hitting undo and find my mistake, but I made some sort of silly mistake down in here. Sorry, I've done that twice in this worksheet because I'm not really paying attention to the end part. I'm not trying to make my point that well, but there it is. All right, now let's see if we can go shorter through these. Let's don't lose our work this time. Let's keep this work because we might can reuse it. Let's do B. All right, B coming up out of it are equilateral triangles. So I can go, great, I'm going to double it from 0 to 2. And so I'm going to get this side of it and then double it. Equilateral triangles are square root of 3 over 4 times the side squared, dx. All right, so square root of 3 over 4 times side squared, and the side is this whole entire thing. So it ends up being 2 of these, 4 minus 6, square root of 4 minus 6 squared. Now let's see if we can use our work to our advantage. All right, so if I take this out, that gives me 2 square root of 3 over 4, or square root of 3 over 2, times the integral from 0 to 2 of 2 square root of 4 minus x squared squared. Now, did I get that answer all by itself? I think that answer is 16 thirds, because that's what I got for, oh no, it's not. Yes, it is. All right, because I squared it and got this 4. I pulled it out and got this 8. And so whatever I multiplied 8 by must have been the integral. Oh, wait, I have to be careful. All right, let's take another step. This is square root of 3 over 2, integral from 0 to 2. If I square all of this, I get 4 times 4 minus x squared dx. So bring this 4 out, and I get square root of 3, 2 square root of 3, because I have 4 square root of 3 over 2. And this part, I think, was the part that was 16 thirds. So I'm getting 32 root 3 over 3. Okay, so that went faster. All right, now let's do the C part. Well, number 2, semicircles. So now coming out of here are semicircles. Be careful that you've got the whole diameter, not the radius. Oh, wait, did I take that into effect on the last one? Oh, that's what I messed up on this one. Let's go back and look at this. That's what I messed up on this. Semicircles, and I said it. Oh, and I wasn't even, I'm sorry, it said semi-ellipse on C. So I should have noticed that. This was semi-ellipse, which you don't have to know the formula for. One day I'll probably go over it with you. But even at that, I forgot that this was not the radius. This whole thing is the diameter. That's why I wasn't getting C right. So you can just omit that. 1C for now. But that's why I missed it. Because I didn't see it as semi-ellipse. All right, now this is a great lesson. Be really careful on the C part with the semicircles. All right, semicircles is going to be, I'm going to double it from 0 to 2. All right, so it's going to be pi over 2 times the radius squared dx. So I would have missed that other one anyway. Be careful because I just said it and then I almost did it myself. All right, so this whole thing, this part right here, which gave us 2 square root of 4 minus x squared, this and this is the diameter. So just one of these is the radius. So the radius is the square root of 4 minus x squared. So pi over 2, make sure you get the radius, not the entire diameter. Pull this out, you have pi, don't forget that pi is there, of 4 minus x squared. So be really careful when you're saying pi over 2 r squared, be sure you know that you've got the radius. 4x minus x to the third over 3 from 0 to 2. Don't forget about your pi. If you're using a calculator, type it in front of math 9. All right, this is going to give me 8 minus 8 thirds and 0. This was the 16 thirds. So 16 pi over 3. And then D. D is isosceles triangles. All right, so let's read this carefully. All right, so we have isosceles triangles with a hypotenuse in the base. I think we have a handle on all of this right here. All right, so what's coming up out of here, drawn it a lot, sorry, are isosceles triangles, so with the hypotenuse is in the base. So here's an isosceles triangle. A root 2, okay? And so sometimes one of the legs will be sitting right here, and this other part will be up here, and the hypotenuse will be coming out of your figure. But that's not what's happening here. If you can imagine someone picking this up, and they're planting the hypotenuse right in the base, and the right angle's coming out of it. So this a squared of 2 is the base. All right, isosceles triangle. So I'm going to go from 0 to 2. So I'm going to double whatever I'm getting. I'm just doing it from 0 to 2, and then I'm doubling it. All right, the area of a right triangle, isosceles right triangle, is 1/2 base times height dx. All right, now I've got to be really careful though, because I have the hypotenuse, and I need these for base and height. And so to go backwards, if you have the hypotenuse, to move backwards, if you have the hypotenuse, you would divide by square root of 2. If you remember that from your geometry. And so watch and see what is in the base of the solid. So it's like somebody picked this up and planted the hypotenuse right there. And so these sides are the base and the height. It doesn't look like much a right triangle. So going backwards, if you're given the hypotenuse is A, your base and your height are going to be over square root of 2. All right, let's find out how long A is. It's right here. This is A. And then I need to divide it by square root of 2 to get these, but let's just find A first. All right, A is that distance, which was square root of 4 minus x squared doubled all the way down. So 2 square root of 4 minus x squared. That's A. And so the sides, I'm going to divide by root 2. So let's get some room here and see what happens. So you got to think about your geometry. All right, so you have 2 square root of 4 minus x squared over root 2. And that would be one of the sides. And the other side, which is at the right angle to it, is 2 square root of 4 minus x squared over root 2. All right, these are going to cancel out because this is 1/2 base times height. Okay, and let's remember, let's carry it up here. right, so it's the integral from 0 to 2. I did double it, but it canceled out with a 1/2. This 2 times 2 is 4. This is square root of 4 minus x squared. And square root of 2 times square root of 2 is 2 dx. So I have 2 square root from 0 to 2. I'm an integral from 0 to 2 of 4 minus x squared dx. Remember, this is 1/2 base times height, and this gives you triangles a little bit of width there on the sides. All right, now I think this was our 18/3, 16/3. So I'm getting 32/3. I'm kind of suspicious of that one. It's late, done a lot. Be my excuse if I'm wrong. 32/3. And what did I get? I think I got, 32/3. Like I said, it's late. All right, so again, I'll say it in the homework. For now, omit 1C. All right, now I'll help you set up some of these others and then you can finish working them. Look for quick ways to work them. All right, so number 3, cross sections. Remember, you're just adding up geometric figures with a little bit of width. I said geometric. All right, the base of a solid is y equals x cubed. Y equals 0. Y equals 0. And x equals 1. All right, now notice this is perpendicular to the y-axis. So let me draw this bigger first of all. I only need this part. X cubed, y equals 0 is the x-axis, and x equals 1. All right, so we have this as our base right here. And now somebody is taking it and slicing it perpendicular to the y-axis. So I'm going to do it probably in terms of y because I'm slicing it this way. And the length of these is right minus left. All right, now why does that work? Remember, your x's are coming from this, just like your y's come from your x-axis. Your x is like if this is all the way out here at 1, and your other x was all the way out here at like 1/2, then you should say 1 minus 1/2 to see what's left in between. So I'm going to be doing right minus left instead of top minus bottom. All right, so we're slicing it this way, and we're going to get ready to add up squares. So I'm going to say side squared dy. My y's are going from 0 to 1, but be careful. See, when x cubed, oh, be careful. Let's see. I need to solve this for x if I'm doing it in terms of y. This is x is equal to the cube root of y, and x is equal to 1. So they intersect when x and y are 1. All right, so I'm going from 0 to 1 this way. And so I'm changing by dy and finding all of these. All right, we have squares, so it's going to be side squared. So right is 1 minus left cube root of y. And let's check our setup. And you can finish it. Make sure you finish it. Okay, and you should be able to check your answer. All right, and then B are semicircles, so be careful. These slices right here across are just diameters, and you have little semicircles. So this is right minus, it's going to be semicircles first of all. So pi over 2 r squared. All right, the radius is not this. It's that divided by 2. So it'd be 1 minus the cube root of y squared divided by 2. Now, once you get this answer, you can keep using it after you fix up the second one. Let's look at our setup. they've got a pi over 8 out in front of theirs. Let's look at ours. We're going to have a pi over 8 also. Because this is going to be a pi over 2, and this is going to be a 2 squared, we're going to have pi over 8 out in front of 0 to 1, because I'm squaring this, and this is 1 minus the square root of 3 squared dy. You'll work this one out, and I think it said the answer was 0.1. So our new answer should be pi over 8 times 0.1. And you keep getting this in there. All right, so next on C, the cross sections perpendicular to the y-axis are equilateral triangles. So these are equilateral triangles popping up out of here. So we have, like, here's one, and if you turned it sideways, it would have a little bit of depth. So equilateral triangles is square root of 3 over 4 side squared. From 0 to 1, you're just doing triangle after triangle after triangle. You can factor out your square root of 3 over 4. And then the last one is semi-ellipsis. So scratch that for now.